Hello and welcome. This mini tutorial is about organizing our data, and as you probably already figured out, statistics got plenty of data, so finding a way to organize it is crucial. First, let's go over the main objectives of this lecture. By the end of this lecture, I'm hoping that you will be able to distinguish the difference between variables and constants, know what a dependent and an independent variable is, and last but not least, understand the levels of measurement. Your book briefly talks about the level of measurement on the reliability and validity chapter, but I find it important to talk about it now since it will better serve you to understand some of the concepts that we will cover before we get into that chapter. So, what is a variable? The definition is a characteristic researchers collect data on. Simply enough, yet lots of us tend to get confused, so let's talk about it a bit more. Anything that the researcher is interested to find out about his sample or population, he or she can turn it into a variable. A variable is something that we can measure. Any question in our survey becomes a variable. As the word implies, a variable is something that it is not fixed, but it varies from person to person. For example, we want to study if there is any association between height and weight. Height is one of the variables and weight would be another. We can then measure both for each participant from our sample, and then we can run our analysis to find that association. Now let's talk about constants. What is a constant? It is any characteristic that is shared by our sample but does not vary. It remains constant. Thus, since it is not changing, there is nothing we can do about it. There is no point for us to run an analysis. In other words, we can only analyze and test variables and not constants. As you can see in the picture, what is a characteristic that our sample shares? They're all sheep, right? That is a constant and there's nothing to debate upon. We could test their age and amount of body fat that they have, since those are two characteristics that probably vary between each sheep, but other than that, the fact that they're all sheep, there's no debate, there's nothing to analyze. We accept that as a fact, and we never analyze constants. Now let's see if we understand the difference between a constant and a variable. Okay? Question to you guys. I am conducting a study on 100 Latino adults. Can one of my variables in my study be race, ethnicity? What do you think? No, it could not be, right? Since everyone in my sample is Latino, so there would be no point to look into race, ethnicity. Race, ethnicity, on the other hand, would become a variable if my sample was composed, let's just say, by 100 US adults of varied ethnicities. Now we're going to talk about dependent versus independent variables. Okay? Usually our dependent variables is displayed on the y-axis and our independent variables on the x-axis. Our dependent variable is the variable that we're trying to predict. We usually suspect that there is a relationship between the two variables, and when doing research, our independent variable serves as the variable that we either manipulate or the variable that we believe has an effect on the dependent. So, that is why y is always a function of x, and we always measure y to see what the effect was based on the fact that it interacted with x. A simple way of remembering and not confusing the two is that the independent is the cause and dependent is the outcome, and we always measure the outcome. Let's take an example so we can make more sense of what I just said. We want to see the impact of caffeine on reaction time in rats. So we get 200 people who agree to be part of our research. 100 get the treatment, which is drinking 15 cups of coffee a day, and 100 get absolutely nothing, placebo, right? So they are going to be the controls. We then measure reaction time on each group, experimental and control, and we check for differences. If we find any differences between the groups who drank the 15 cups of coffee on reaction time and the groups that did not, then we can say that consuming caffeine right? Our independent variable, that's what we manipulated, had an effect on reaction time, which is our outcome, our dependent variable. Now that we covered what a variable is and what is the difference between an independent and dependent variable, we need to talk about the fact that variables differ greatly in regards to type. What do I mean by that? Depending how a variable is measured, it can fall under one of the following categories that you can see here: nominal, ordinal, interval, and ratio. Okay, we're going to talk more analytically about each one of this. Now, again, we will revisit those concepts when you get into the reliability and validity concept. If you want, you can probably go into your book and take a look what it says right now. But I believe the information that I'm giving you is going to be enough for you to understand. But take into consideration that it will take practice to truly be able to differentiate between the different levels of measurement when you see a variable. So let's get started with nominal. Nominal variables are categorical variables. They are variables that you could not measure with numbers in a mathematical sense. You could count the frequency, but numerically it would make no sense. For example, in our picture we see a group of teenagers consisting of boys and girls. All those can only be classified under categories. You could have a category for teenagers, right? If you were testing differences between teenagers and adults, right? Or you could have a category for boys and girls. These are variables since you can test the difference between the two groups, but you could not assign them any numerical value that would make sense. You would simply compare boys and girls. Now, since we're dealing with categories that have no numerical value, we need to organize them in a way that we can analyze them using statistical software such as SPSS. When we enter a categorical variable, we need to assign numbers to each category. So males can be 0 and females can be 1. These are not numbers that we can perform any high-level math with, but are a way of organizing our data. Here are some more examples of nominal variables. We talked about gender already, but you could also have a variable that asks participants in which CSU school do they go to. And you have the following preset categories in SPSS. So CSUF can be number 1, CSU Long Beach can be number 2, CSU LA can be number 3, and so on and so forth. There are several examples of categorical variables that you probably can think of. For example, what city do you live in, right? So you can have like a drop-down window on your SPSS that we say number 1, Anaheim, number 2, Fullerton. Are you single or are you married? And so on and so forth. There's several variables that are categorical. What I want you to observe is the fact that when you ask your participants these questions, usually the answer is yes or no, or some form of preset answer, okay? Like, what city do you live? And you're going to just say a city and it's done, okay? There's no numbers that you can probably, like, for example, what is your weight, okay? And that would be, for example, 150 pounds for one person, 160 pounds for another, and so on and so forth. Here you would get a variable that is in word form, okay? Now, some of you probably wonder, why do we need to assign numbers to categories and we just don't let it be, right? Well, for two reasons. One, because statistical software need numbers to perform analysis, and second, to expedite the process of data entry. Can you imagine? You have 1,000 participants and you're dealing with the ethnicity variable, and every time you enter info on one participant, you have to type in his ethnicity. It would be a lot easier if we preset our categories, and then anytime we have a participant from a specific ethnicity, we can simply type in 1 for white, for example, 2 for Hispanic or Latino, 3 for Asian, and so on and so forth. Ordinal variables are variables that are presented in categories as well, but now here order matters, and the distance between each category or ranking can differ. Let's see a few examples to understand the concept. You have a picture with a bunch of hot sauces and you could rate them as mild, medium, medium hot, hot, super hot, and burning my mind hot. These are all categories, but there's an order to it. You go from being mild to beyond hot. Also, you cannot really say that the medium is twice as hot as the mild and the medium hot is exactly 3 times as hot as the mild. So distance between the spiciness levels differs. Likewise, when you have a race, right, someone will come first, someone will come second place, and another person will come a third place. There's no equal distance between them, but the categories would be gold, silver, and bronze. The gold is much higher in order than silver, and silver is higher than bronze. So again, the order matters. In the previous example of nominal variables, if you have the categories of boys and girls, it really does not matter if you assign girls to be a 0 and boys to be a 1. The order there does not matter, but in ordinal, order matters, and that is the main difference between the two. Again, here's a visual of the hot scale moving from hot to hottest. Also, I need to mention that in the PowerPoint version of this lecture, I provide you with more examples, but due to the fact that I need to be aware of time with the recorded lectures, I have to skip a few of them. Interval variables are numerical variables, okay? So as we can see slowly, we're elevating, we're becoming more sophisticated, okay? So they're equally spaced, and there is the main difference here, because we're going to have ratios, you're going to see the next type of level of measurement, is that interval variables have no absolute zero, meaning that zero does not have the meaning of zero the way you know it. And what do I mean by that? Usually, zero equals nothing. If something weighs zero, that means it has no weight. But if you say that the outside temperature is zero, that does not mean that there's a lack of temperature, but it is very cold. Some more examples of interval variables would be time in terms to what time is it? It can never be 0 time. The time never stops. But if I ask you how long did it take you to do something and you didn't do it, then that means that you took a 0 time to do it. So in that case, 0 has the meaning of 0 as you know it, and it would change time from being measured to a ratio level instead of interval. Sea level, we tend to measure it as 0 feet for ground. Well, the truth is that the ground continues underneath the sea level. So it is not truly an absence of ground, simply it is at the lowest level before you reach the sea level. The last and most advanced level of measurement would be ratio. Ratio has all the qualities of the previous one, plus the fact that it has a numerical value of the true 0. Here we're talking about numbers as you know them. If you drink 0 grams of soda, that means that you did not drink any. Any person who weighs 150 pounds is 50 pounds more than the person who weighs 100 pounds. We can now perform advanced analysis because we're dealing with true numbers and all their qualities. 0 sit-ups means that you did not do any sit-ups. True 0. One last thing before we end this lecture is that interval rate and ratio variables can be measured at a continuous level, meaning that we have decimals. For example, the temperature outside can be 55.5 Fahrenheit and you can drink 30.4 ounces of soda. But you can only have 1 or 2 kids, not 1.5. So number of kids you have would be categorical, with categories ranging from 1 kid, having 2 kids, 3 kids, and more. There's no halves. Also, birth order would be an ordinal variable because you would have categories of firstborn, secondborn, thirdborn, but here the order matters. But you wouldn't have anything in between. In other words, interval and ratio are the only ones that we can perform calculations, with ratio having the most qualities out of all. All right, so hopefully this lecture was helpful, and before we end it, let's reiterate what we just covered. In statistics, we distinguish between variables and constants, okay? And we only test variables since we're the only ones that their values change, and we're only interested in that change. We have two types of variables, independent and dependent variables. With independent is what we manipulate, and dependent is what we measure, the outcome. There are 4 levels of measurement: nominal, ordinal, interval, and ratio. The first two, nominal and ordinal, are categorical, with the main difference is that in ordinal order matters, and the last two, interval, ratio, are numerical, with the main difference that the ratio has a true zero. So that's it with this lecture. I would recommend that you take a small break and then move on with the second lecture of the day. Talk to you soon.